Exercise 9.1. Draw a diagram to show how each of the following sequences continues and find the next three terms in each case. Part A, 5, 7, 9. So, and so on. In this case, we can see that this is plus 2, this is plus 2, plus 2. This is how we are getting each next term and so on. So this might be the diagram, and continuing the same pattern, the next three terms would be 15, then 17, 19. How do we get, like for example, after this 13, adding two more, we get 15, and then yet adding two more, 17, and adding two once again, we get 19. So these are the next three terms of this sequence. Okay. Now for part B, 3, 8, 13, 18, 23, and so on, we can observe that this is the next term is got by adding 5, then adding 5, then adding 5, and then adding 5. So the next three terms would obviously be got by adding 5. So 23 plus 5, that is 28. Then adding 5 more, we get 33, and then adding 5 more, we get 38. So these are the next three terms of part B. Then for part C, 3, 9, 27, 81, 243, and so on. We see that the next term in this case is not got by adding something, because if you compare these two consecutive terms, one after the other, so if you get 9 by adding 6 to 3, you cannot get 27 by adding 6 to 9. So that means there is some other rule that is being applied over here. So we can say that the next term is got by multiplying 3, and then after 9 you multiply 3, you get 27. Then again by multiplying 3 you get 81, and so on. So to get the next term after 243, obviously we need to multiply it by 3. So multiplying by 3, you get the next term, that is 729. Then multiplying 729 by 3, we get the next term of this sequence, that is 2187. And then multiplying this by 3, we get the next term of the sequence, that is 6561. So this is how we get the next three terms of this sequence. So then for part D, for example, 0.5, then 2, then 3.5, then 5, then 1, 6.5, and so on. We observe the similarity that is being applied into this is adding 1.5 to 0.5, you get 2. Then adding 1.5, we get 3.5. adding 1.5, we get this. Adding 1.5, we get 6.5. So the next terms should also be 6.5 plus 1.5. So that is 8. So the next term of this sequence should be 8, and then adding 1.5 to 8, 8 plus 1.5, that gives us 9.5. So 9.5, and then 9.5 plus 1.5, that is 11. So the next three terms are 8, 9.5, and 11. Okay. Then it is part E, for example, 8, 5, 2, -1, -4. Now we can obviously observe that the numbers are decreasing. So that might be the case that either the numbers of the sequence are got by dividing uh, the previous term by some amount or by subtracting. So in this case, the pattern that seems and that can easily be observed is uh, by subtraction. So what is being subtracted? We need to assess that thing, and that's how we would be able to get the next three terms of the given sequence. So by subtracting 3 from the successive terms, we get the next term of the sequence. So after -4, we need to see that -4 minus 3, that will give us -7, and then -7 minus 3, that will give us -10, and then -10 minus 3, that will give us -13. So the next three terms are -7, -10, and -13. Then it is part F, 13, 11, 9, 7, 5, and so on. That tells us that we need to subtract 2 to get the next term. So the next term after 5, that would be 5 minus 2, that is 3. Then 3 minus 2, that is 1. And then 1 minus 2, that is -1. So this is how we get the next three terms of this sequence. Okay. Then it is part G, 6, 4.8, 3.6, 2.4, and 1.2. Again, we can observe that the next terms are being decreased. So the number that we are getting to be subtracted, 6 minus 4.8, that is 1.2. So 1.2 is being subtracted in this case as well, in this case as well, and in this case as well. So after 1.2, we subtract 1.2, that is 0. So the next term is 0. After 0, 0 minus 1.2, that is -1.2. So the next term is -1.2, and then -1.2 minus 1.2, that is -2.4. So the next term after -1.2 is -2.4. Okay. Then for part G, after part G, this is part H, 2.3, 1.1, then negative 0.1, negative 1.3, and so on, we can see that 2.3 minus 1.1, that is 1.2. That means we are subtracting actually 1.2. Again, by subtracting 1.2, and again by subtracting 1.2. So after negative 1.3, by subtracting 1.2, we get negative 2.5, and then negative 2.5 minus 1.2, that will give us negative 3.7, and negative 3.7 minus 1.2, that will give us negative 4.9. So these are the next three terms of the sequence. Okay, so that completes our question number 1. For question number 2, uh, find the next three terms in each of the following sequences and explain the rule that you used in each case. Part A, that is 1, negative 3, 9, negative 27. We see that these are the multiples of 3, like the terms are got by multiplying 3, though 1 is not the multiple of 3, it is a factor of 3. So we see that the next term of the sequence is got by multiplying by 3. But one thing that we need to observe is that first term is positive, then second one is negative, then positive, and then negative. So the terms are changing the signs alternatively. So what pattern we can observe is that the number that is being multiplied, that itself should be a negative number. So after negative 27, the next term should be a positive term. That can be got by multiplying with a negative number, and that is negative 3. So the rule could be multiply the previous term by negative 3. So in this way, we can get the next term, negative 27 times negative 3, that would be positive 81. Then 81 times negative 3, that will be negative 243. And then negative 243 times negative 3, that would become positive 729. So these are the next three terms of the given sequence. Okay, then it is part B, Monday, Tuesday, Wednesday, Thursday. Obviously, these are the days of a week. So the rule could be uh, write down the next day of the week. Okay, and the next three terms, obviously, after Thursday, it is a Friday, since this sequence is using only first two letters of that day. So Friday, for Friday, I should write FR. After Friday, this is Saturday, so I should write S and A only. And for Sunday, I should write S and U only. So these are the next three terms of this sequence. Okay. Uh, for part C, A, C, F, J, and O. Okay, let's see what is the pattern that is being followed in this case. Uh, After A, obviously that is B. So we have skipped B and then we have got C. Okay. Then after C, uh, in the sequence we have got F, and in the English alphabet we have got D and E. Okay. And then after F, G, H, and I. And then this is the next term of the sequence, that is J. And after O, uh, after J, what we need to observe? After J, it is K, L, M, and N. And then we have got O. So the pattern could be that what we are doing is we are skipping one alphabet, then we skip two alphabets, then we skip three alphabets, and then we skip four alphabets. So what could be the rule? That is skip an extra or additional alphabet. Okay. Uh, so in the same way, then after O, what should I get? Last time I've skipped four. So then after O, I need to skip P, Q, R, S, T. I need to skip all of them. Then it should be U. So the next term is U. Okay, after U, V, W, X, Y, Z, and one more. Starting once again, A. Because here we skipped 5 and I need to skip 6 now. 1, 2, 3, 4, 5, 6. So I need to skip these 6 alphabets. After that, I should get B. So this is the second term. Okay. After this sequence. And then after B, uh, now I need to skip 7. B, then C, D, E, F, G, H, and then I. 1, 2, 3, 4, 5, 6, and then 7. These are the 7 letters that I need to skip. And the next term is J. So the next three terms of the given sequence are U, B, and J. So that completes this question. Okay. Then it is question number 3, an investigation question. The first term that is represented by T1 of a sequence is 5. The term to term rule for the sequence is add x. Find the value of x that will give you each of these sequences. Part A, every second term is not an integer. Okay. Uh, if T1 is 5 and the rule is I need to add x. So T2 can be got by 5 plus x, and I need to have that every second term is not an integer. Okay. We see, like for example, if we add half into it, like for example, that would give me 5.5. Now this is not an integer. And then if I add zero point 0.5 into it, that it would become 6. That is an integer. So second term is not an integer. The third one is an integer. T3 will be 5.5 plus 0.5, that is 6. Now this is an integer, but this is not an integer. And then T4 will be 6 plus 0.5, that is 6.5. This is not an integer, and then the next term, that is 6.5 plus 0.5, 7. That is an integer. So what we may observe that the value of x should be 0.5. So x should be equal to 0.5. That fulfills our requirement for part A. Okay. Now for part B, every second term is a multiple of 10. Uh, every second term is a multiple of 10. Like for example, we can say that what we need to do is the addition of half of 10. That means addition of 5. So I should be getting for part B, it should be uh, if T1 is 5, then T2 should be 5 plus x, which if I add 5 into it, now that becomes 10. Now T3, 10 plus 5 again. Now this is not a multiple of 5, but the next term will become 20. That is a multiple of 10. Multiple of 10, sorry. Then T5 will be 20 plus 5. That is 25. That is not a multiple of 10. But the next term, that is 25 plus 5, 30. That becomes a multiple of 10. So what should be the value of x then? That is 5. So x should be 5. That means you need to think that what should be added so that this condition can be fulfilled. Now, for part C, T1 is 5. So T2 is 5 plus x. The condition says that the next term should be lesser than T1. So what should I add into 5 so that the next term is lesser than 5 itself? That means I should be adding a negative number. X should be a negative number. Like for example, if I add negative 1, I get 4. After this T2 for T3, if I add negative 1, I get 3. And for the fourth term, 3 plus negative 1, I get 2, and so on. You see that every next term is being decreased from the previous term. That means the next term is going to be lesser than or smaller than the previous term. That might not be the case for x equals to negative 1 only. That could also be the case if I replace, uh, like for example, any other value of x in negative. For example, if I take the value of x to be negative 2, that will be 3. So 3 plus negative 2, that is 1. And then 1 plus negative 2, that is negative 1. So this condition is being fulfilled in this case as well. So we cannot fix any particular value of x, but what we can do is that x could be any negative number, or you can say that x should be less than 0. So that completes this exercise 9.1.